Okay, so today we are going to talk about 11.1 area of parallelograms and triangles. So area is basically how much space a two-dimensional object can take, right? So two-dimensional objects that we can consider are squares, rectangles, circles, etc., 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 right? So if I were to give you an example, something like this is my rectangle. The goal is to figure out how much space that this two-dimensional object can take, okay? And we figure that out by just using some sort of formula, okay? So the first thing that we're going to be dealing with here is the area of a parallelogram. Now, the area of a parallelogram is the product of a base and its corresponding height. Okay, so product just means multiplication. So I'm multiplying the base and the height together. So here's the formula that you need to know. A is equal to BH, or A is equal to the base times the height. When we're trying to determine what the base and the height are, we just see if the two things are perpendicular to each other. So I'm going to make a note right here. The base and the height are always perpendicular to each other. Okay, so here is my parallelogram. A parallelogram, if you forget, is basically a quadrilateral, which means it has four sides, where it has two pairs of opposite sides parallel. Okay, so here's my quadrilateral, 1, 2, 3, 4, and it has two pairs of parallel sides. Okay? And don't forget, with a parallelogram, the opposite sides are congruent as well. Okay, so don't forget that fact as we're going through these problems here. So, this is the base of the parallelogram, and perpendicular to that is the height. Okay, so it has that little upside down T that you can see, right? So this is the base, this is the height. The height will never be slanted. It's always going to be a straight line. Yes? So they're perpendicular to each other, so it's easy to figure out what's the base and the height. Okay? So let's go ahead and take a look at example number 1. It says find the perimeter and area of each parallelogram. And we're going to be using the Pythagorean theorem if needed to find some missing parts. So the first thing that we're going to do is look at example 1a. I have a parallelogram. The goal here is to figure out the perimeter, which just means the total distance around the figure. I'm going to add up all the sides, right? And then I'm going to find the area, which I will use this formula here. A is equal to B times H. So here's what I need to do. In order for me to find the perimeter of this parallelogram, I need to add up all the sides, right? So things are not filled in for us. I can see that we have 4 inches here. And because we have a parallelogram, that means that opposite sides are congruent. So if that's 4 inches, then that means that this side here is also 4 inches. And if this side here is 10 inches, you know for sure that this side is also 10 inches. Okay? So I'm going to add up all the sides here. I have 2 10s, right? So I'm going to say 2 times 10 plus I have 2 4s, so I'm going to write 2 times 4. So I have 20 plus 8. That'll give you 28. So since we're in the area unit, I do want you to put units this time. So what's the unit for this parallelogram? Inches, right? So it should be 28 inches. So don't forget to write the units this time. Okay, otherwise you're going to get points taken off on a quiz or a test. So 28 inches. We write inches because we are in one-dimensional land, right? When we're dealing with area, we typically square the unit. So in this case, don't do anything besides writing inches, but when we get into area, so area equals base times the height, right? You definitely need to square that particular unit, okay? So remember, the base and the height, they're always perpendicular to each other, okay? So Emma, what is the base of the parallelogram? 10, right? So this is 10. Okay. So I have 10. And then Penelope, what is the height? 5. Okay. So hopefully you can see it. This is the base, and perpendicular to that is the height. So we have 50 what still? 50 what?
Inches.
Inches. If it's area, we need to do what? What do we do, Sydney?
Square it.
Square it. 50 inches squared. See, since this is a two-dimensional object, and we're dealing with area, I'm trying to figure out how much space this thing can take. You need to square the unit. Since it's two-dimensional, we put a 2 for the unit. Okay? All right, so that's the first one. Let's take a look at the second one here. All right, so remember, we're trying to figure out the area of this parallelogram. Okay? We need to figure out the area of the shaded figure. You can see that we have this exterior stuff. That's going to help us figure out this one missing part. Okay? So, first things first, we need to find the perimeter, right? So I know this side here is 23. That means this side is 23 as well. Okay? So I have 2 times 23 plus something else. I don't know what this side here is. Okay? So you can't just write 2 times 23 plus 2 times 24. No. I need to figure out what this side length here is, and once I figure this out, I can figure out this thing here. Okay? So how would I figure out this missing side here? I do what? Yeah, it says right there, Pythagorean theorem. So I will have to use Pythagorean theorem for this right triangle here, right? So let's go ahead and put that over here. I have a squared plus b squared equals c squared. All right, so a is 7 squared plus b, 24 squared, equals c squared. Remember, the side that we're trying to figure out is across from the 90-degree angle. This is the hypotenuse, right? So that's going to be my c. And once I take the square root on both sides, you're going to get 25 equals c. So I have 7, 24, and this side here is 25, okay? And that is, by the way, you didn't have to use the Pythagorean theorem formula because this right here is a Pythagorean triple, right? So if you remember your triples back in Unit 8, I think you should be golden. So 7, 24, 25, if this side is 25, that means this side is 25. So I have 2 times 23 plus 2 times 25. Add them all up together, you get 96 what here? 96 what? 96 feet. Perfect. All right, next thing is to figure out the area. So area is equal to the base of the parallelogram times the height of the parallelogram. So what's the base of the parallelogram? 23. 23. And then the height should be what here? Let's see. Try this one. What's the height?
24.
It is indeed 24. Y'all, it is not 25. Okay, 25 is slanted. That's not the height. It needs to be a straight line. So we can see that the height of this parallelogram is 24. Okay, so I can go ahead and redraw that same line over here. And you can see how tall this dang thing is. It is 24 feet long. So 23 times 24. And again, since this is 24, it's perpendicular to that 23 right there. Okay, so 23 times 24, that is 552 what?
Feet squared.
Square feet, perfect. Feet squared, square feet. Okay? Any questions so far? Okay? All right. So example number 2, it says use special right triangles to find the missing dimensions, then find the area of each parallelogram. Okay, so I'm going to go ahead and write to the side over here. We have 45, 45, 90, and then we have a 30, 60, 90. So if it's across from 45 degrees, what do you label that side? Or what do you set that side equal to? A. So if that's 45 and this is 45, then this side has to be A as well. Across from the 90-degree angle, you set that side equal to what? A root 2. A times the square root of 2. Okay? And then 30, 60, 90, across from the 30-degree angle, what do I set that side equal to? What do I set that side equal to? If it's across from the 30-degree angle, it should be what? Nope. It's the smallest side of that figure. It'd just be A. What about 60?
A squared.
Nope. No.
A
A root 3. And then 90 would be, 90 would be what?
2A.
2A. Okay? So we're going to be using that to figure out the area of these two parallelograms. So example A. All right, so we know that this side is 17. So this side is also, so let me go ahead and write that, 17 yards here. So we have the base, right? So the area is equal to base times the height. I know what the base is, that's 17, but what is the height? Well, I don't know, right? So this height here is missing. We got to use special rights to figure out that missing side. All right, so here's 45, and if this is 90 degrees, and this is 90 degrees, and this is 45 degrees here, okay? So across from 45 degrees, this is 9, okay? So if this is 45 degrees, then this side has to be 9 as well because it's an isosceles right triangle. So I have my height. I don't really need to figure out what this side here is. I'm only trying to figure out the area. I don't need to find the perimeter at all. So that's not what it's asking me to do. So I have 17 times 9. That is going to give me, what's 17 times 9? That is 153 square yards. 153 square yards. All right, moving on to example B. I got a 30, 60, 90 here. How do I know? This is 30, this is 90, and this is 60. This side here is 32, so this whole side over here is also 32. Okay? And then I need to figure out the height of this thing, okay? So across from 30 degrees, this side here is A. Across from 60 degrees, that has to be A root 3, right? So if this is A root 3 and A is 12, then that means that this side here is 12 root 3. So I have my base, which is 32, and the height. So A equals base times height. The base is 32, and the height is 12 root 3. Okay, so remember, when we're multiplying these two things, it's always the coefficient to the coefficient, and then the radicand to the radicand. So I'm multiplying this 32 with the 12, but you do not distribute the 32 to the root 3, or you do not multiply the 32 and the root 3 together. Don't do that. So it's 32 times 12, which is, 384. And then you slap on the root 3. Okay, so it's 384 root 3, what? Square meters, right. Okay? All right, so now what we're going to do is we're going to move on to area of a triangle. So the area of a triangle is essentially half the product of the base and its corresponding height. So here's the formula. A equals 1/2 BH, or A equals BH all over 2. So just like the parallelogram, the base and the height, so the base and the height will always be perpendicular to each other. So you can see that by looking at this diagram here. Here's the base, and perpendicular to that is the height. So they intersect at a 90-degree angle. So let's take a look at example number 3. It says find the perimeter and the area of each triangle. We're only needing to find the area of the shaded figure, but we do have some exterior stuff that'll help us find that one missing side if we need to use that, okay? So, let's start off with the perimeter here. So the perimeter, that's easy. I have 19 plus 41 plus, do I write 30 here? Do I write 30, yes or no? Do I write 30, yes or no? No, because it's not part of that shaded figure. So what do I need to do to figure out this one missing side here? Pythagorean theorem, okay? So, I'm going to do a squared plus b squared equals c squared. What's a? What's a? I'm talking about if we're trying to figure out this missing side, right? What's a? 27, right? This is a right triangle. We can only use Pythagorean theorem when we have a right triangle. This is not a right triangle, okay? So a is going to be 27 squared plus what's b? 30 squared, and then c is what we're trying to figure out. Okay? So, you're going to get 1,629 equals c squared, and if I take the square root on both sides, you're going to get approximately 40.4 inches. So this side is 40.4 inches. So I have 19, I have 41, and I have that 40.4 inches. So I can go ahead and add them all up, and you should get approximately 100.4 what? Since we're dealing with perimeter, it should be 100.4 what? What's the unit? Inches, just inches, okay? And then to figure out the area, it's 1/2 base times the height. So 1/2, what's the base of the triangle that I'm looking for?
19.
It would be 19, and then the height should be what? 30. Okay, so again, here's 19, here's 30. This is 19, this is 30. They should be perpendicular to each other, okay? So 1/2 times 30, that'll be 15. 15 times 19, that is 285 square inches. Square inches, okay? Any questions about this one? Any questions? Okay. Let's take a look at B. So I need to find the perimeter. So P equals, here's 29. I don't know what this side here is. And I don't know what this side here is as well. Okay? So what I need to do is I need to use this exterior triangle to figure out that one missing side. So I should use what? Pythagorean theorem, okay? So, I have 6, this missing side, and this would be 10. So if I use Pythagorean theorem, or if I know my triples, this would be a 6, 8, 10 situation where this 8 is going to be your A or B value when you plug into the Pythagorean theorem, okay? So 3, 4, 5 is a Pythagorean triple. 7, 24, 25 is a Pythagorean triple. 6, 8, 10 is a double of 3, 4, 5. So I can just say 6, 8, 10. multiplying the 3, 4, 5 by 2 each. Okay? So, I have 29. I have 8. So I'll put plus 8. But I don't know what this side here is. So how would I figure out this one missing side? Yeah, I got to use the Pythagorean theorem again. So I will do a squared plus b squared equals c squared. A is going to be 8, so 8 squared plus b, that's 29 squared, equals c squared. And now if I take the square root on both sides, c is approximately 30.1. So this side here, which is across from the 90-degree angle, is 30.1. Okay, so 29 plus 8 plus 30.1. Add them all up. You should get 67.1 centimeters. Okay, and then the area, A equals 1/2 base times the height. So 1/2 of, what's the base here? Let's see. What's the base of the triangle that we're looking for? 29. And then the height should be what? What's the height of the triangle? 8. So I can do 1/2 times 8, which is 4. So 4 times 29, that is 116 centimeters squared. Any questions so far? Okay. Now what we're going to do is we're going to get into the territory where we use the formula and go backwards. Okay, so let's go ahead and flip to the next page here. So example number 4, it says use the area to find the missing measures. Okay, so what figure is this? What is this figure? It's a triangle, and I should use what formula? What's the formula for a triangle? 1/2 base times the height. Okay? So 1/2, do I know what the base of the triangle is? What is that? 34. Do I know what the height of the triangle? What is it currently? X, right? So X. Okay. Oh, do I know what the area of this triangle is? What is it? 357, okay? So my goal here is to find the value of x, which in this case is the height, right? So I can go ahead and do this. I have 357 equals 1/2 of 34, which is, what's a half of 34? 17 multiplied by the x, okay? So I have 17x on the right-hand side. I should do what on both sides to figure out what x is? Divide both sides by 17. So x is equal to 21 what? If I'm trying to only figure out the height, it should be just inches, okay? So if you're finding a part or a segment, it should be one-dimensional. So you just only write inches. If you're dealing with area, the unit needs to be squares. But in this case, you just write inches, okay? All right, let's try and look at we should look at example 4b here. This is a what type of figure? A parallelogram. So the formula for a parallelogram is what? Base times the height. A equals BH. What's the base of the figure? 8. What's the height? X. What's the area? 148. I need to do what on both sides? Divide both sides by 8. So x is equal to what? 18.5 meters. Okay. Questions about these two problems here? All right. Now, we're going to go ahead and move on to this formula here. It is huge formula. It's called Heron's formula. Heron's formula essentially just means that if you have all three lengths of the sides of a triangle, in order to find the area, but no height is given, then we use this formula. So basically what I'm trying to say is Heron's formula relates the lengths of the sides of a triangle to the area of the triangle in case you don't have the height, where A, B, and C are the side lengths, and S is equal to what we call the semi-perimeter, which just means half the perimeter. So in order for you to do this problem, you first need to figure out what the semi-perimeter is, okay? So the semi-perimeter is equal to all the side lengths. So you add up all the sides. Then once you're done with that, you divide by 2. That's how you find the semi-perimeter, okay? And then we will use the Heron's formula, which is equal to, A is equal to the square root of the semi-perimeter times the quantity of the semi-perimeter minus A times the quantity of the semi-perimeter minus B times the quantity of the semi-perimeter minus C. Okay? So let's take a look at this example here. Example 5 says, find the area of the triangle with the side lengths 12, 16, and 22 meters. So you don't have a height. So let's make a note here. No height given. So use Heron's. Okay. So I have 12, 16, and 22. I'm going to write A, B, and C respectively. The first thing that you have to do when you do Heron's is you need to find the semi-perimeter. So it's S equals the A plus B and the C together. So it's 12 plus 16 plus 22, and then you're going to divide all of that by 2. So 12 plus 16 plus 22, that's 50. Divide by 2, that's 25. Okay? So when you put 12, 16, and 22, make sure that you put parentheses around those numbers, and then divide by 2 because order of operations. And now what I'm going to do is I'm going to use Heron's formula. So A equals, again, it's the square root of S times the quantity of S minus A times the quantity of S minus B times the quantity of S minus C. So since I already figured out what S is equal to, I'm going to write 25 times the quantity of 25 minus, so S minus A is 12, so I write 25 minus 12 times the quantity of 25 minus 16 times the quantity of 25 minus 22. Okay, let's see. I'm going to grab my calculator. All right. And I'm just going to input it exactly how it's presented on the paper. So I'm going to do second x squared 25 parentheses 25 minus 12, close it. Another parentheses 25 minus 16, close it, times the quantity of 25 minus 22. And then I'm going to hit enter. And we're going to round, it doesn't say what to round. We're going to round this to the nearest tenth. So the area of this is approximately 93.7 what? Square meters. Perfect. Okay. All right. So again, we use Heron's where you are given the side lengths, but no height is given. Henry.
On the quizzes and tests, is there going to be a formula chart, or are we going to have to memorize it?
You will be given a formula chart, but you have to understand how to use it. Okay? All right. Let's take a look at example 6. It says the base of a triangle is twice its height. If the area of the triangle is 49 square feet, find its base and the height. So the figure that we're dealing with is what? What are we dealing with? A triangle. And the key word here is what? What are we dealing with here? The what of the triangle? The what of the triangle? The area of the triangle. And the area formed for a triangle is what? What's the formula? 1/2 base times the height. Okay? So, if the base of a triangle is twice its height, what is the height? Do we know what the height is? Do we know what the height is? Yes or no? If we don't know what the height is, we should call it what? If we don't know what the height is, what should we call it? X. Okay? And the base is twice the height, or 2x. And then the area, what's the area? Do we know the area? 49. So I'm going to go ahead and plug everything in. 49 equals 1/2, and the base is 2x times the height, which is x. Okay? Y'all, I know what 1/2 of 2x is. What's a half of 2x? Just x, right? So this is going to become 49 equals x times x. X times x is what? X squared. A lot of you on the test wrote x plus x and then said that was x squared, which is not correct. X plus x is 2x. X times x is x squared. So I'm going to go ahead and move it over here. 49 equals x squared. And then to solve for x, I have to do what? Take the square root on both sides. So x is equal to 7. Oops. X is equal to 7. Nope. Just feet. Or I should say, since x is equal to 7, then the the height is 7 feet. And then the base is just going to be 14 feet. Okay? So again, that's just, here's a word problem and you're working backwards. All right. Example number 7, it says the area of a parallelogram is 27 square feet and the height is 6 feet longer than the base. Find its base and the height. So what figure am I dealing with here? A parallelogram. Okay, so what am I dealing with here with a parallelogram? The what of a parallelogram? The area. What's the area of a parallelogram? So A equals the base times the height. All right, do I know what the area is? It's 27. Do I know what the base is? No, because it says the area of a parallelogram is 27 square feet and the height is 6 feet longer than the base, and it doesn't tell me what the base is. Since I don't know what the base is, I call that x. And then the height, how do I represent h? X plus 6. So 6 feet longer. I'll write that as x plus 6. Okay? So the base is x. The height is, you got to put parentheses, x plus 6. And then I have something from the parentheses I should do what? Distribute, right? So multiply or distribute. So 27 equals x squared plus 6x. You can see it. Here's x squared, and here's an x. I should do what?
27.
Perfect. Subtract both sides by 27, so you have 0. Let me go ahead and just do this. I'm going to rewrite it over here. So I'm going to write x squared plus 6x minus 27 equals 0. X squared plus 6x minus 27, I should do what? If you have this, you should do the x method. Maybe you want to do the quadratic formula, but that's going to take a little bit. It's okay. I'm just going to go ahead and use the x method here. What goes up top?
Negative 27.
Negative 27. What goes down below?
6.
6. What two numbers multiply together? That'll give me negative 27, but add up to 6. -3 and 9. So -3 times 9. Okay, that's -27. But if I add these two numbers, that's just going to give me 6. Perfect. So how should I rewrite x squared? How should I rewrite x squared plus 6x minus 27?
X minus 3 and x plus 9.
Equals 0. And I'm going to use something called the zero product property. So I take x minus 3 and set that equal to 0. X is equal to what?
3.
3. And if I take x plus 9 equal to 0, x is equal to
Negative 9.
-9. The best x value is always positive. So therefore the answer is,
3.
or x is 3. And this right here is my extraneous solution. So if x is equal to 3, am I done? What does it say? Good. So if the base is x, but we know that x is equal to 3, the base is 3 what? 3 feet, just feet. And then the height is x plus 6, therefore it's 9 feet. Any questions so far? Okay, great. That was wonderful.